Our lesson today is on designing studies, samples, and surveys. We'll take a look at population and samples in a sample survey, identifying voluntary response samples and convenience samples, describing how to use a table of random digits to select a simple random sample, describing simple random samples, stratified random samples, and cluster samples, and explaining how undercoverage, non-response, and question wording can lead to bias in a sample survey. The distinction between population and sample is basic to statistics. To make sense of any sample result, you must know what population the sample represents. The population in a statistical study is the entire group of individuals about which we want information. A sample is part of the population from which we actually collect information. We use information from a sample to draw conclusions about the entire population. So we collect data from a representative sample and then make an inference about the population. The population then, as a side note, is the group of individuals we want to know about, not necessarily the population we can make inferences about in every case. For example, if there were some individuals who were not eligible to be selected from the sample, we would not or should not make inferences about them, even if we want to. Here's an example of identifying population and samples in settings. Part A. The student government at a high school surveys 100 of the students at the school to get their opinions about a change to the bell schedule. In this case, our population would be all students at the school. If they give a specific name of a school, always name the school as well. Our sample, then in this case, would be the 100 students surveyed. Next example, the quality control manager at a bottling company selects a sample of 100 cans from the from the production line every hour to see if the volume of the soda is within acceptable limits. Our population are all cans produced from that hour. Our sample are the 10 cans inspected. We often draw conclusions about a whole population on the basis of a sample. Choosing a sample from a large, varied population is not that easy. So we have to do step 1, define the population we want to describe. Step 2, say exactly what we want to measure. A sample survey is a study that uses an organized plan to choose a sample that represents some specific population. And then step 3, decide how to choose a sample from the population. Each month, the Conference Board takes a representative sample of 5,000 households and asks them 5 questions about their appraisal of current business and employment conditions and their expectations regarding business conditions, employment conditions, and total family income 6 months from the time of the survey. For each question, there are 3 possible responses: positive, negative, and neutral. These are combined into an index which is calculated relative to the value of 100 in 1985. In May of 2010, the index stood at 63.3, which was weak by historical levels, but an improvement from the previous month. This is how consumer confidence is measured. So how can we choose a sample that we can trust to represent the population? There are a number of different methods to select samples. Choosing individuals who are easiest to reach results in what's called a convenience sample. Convenience samples often produce underrepresentative data. The design of a statistical study shows bias if it is systematically favoring certain outcomes. Convenience samples are almost guaranteed to show bias. So are voluntary response samples, in which people decide whether to join the sample in response to an open invitation. By definition, a voluntary response sample consists of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions, often in the same direction, are most likely to respond. Another problem with voluntary response samples is people can respond more than once. American Idol and Dancing with the Stars are examples of polls that use voluntary response samples. In May of 2010, the Los Angeles City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The Los Angeles Times conducted an online poll that asked if the City Council was right to pass a boycott of Arizona. The results show 96% of the 41,068 people in the sample said no. Does this result represent the opinions of all Los Angeles residents? Explain. In this, I would give a response as the following. The voluntary response sample only represents opinions of those who participated in the poll. The members of the sample probably feel much stronger about the issue than those who chose simply not to participate. In these, what is the sampling method used? Convenience sampling or voluntary response sampling? Example, a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of the crate before deciding whether to buy all of the oranges. So in this example, again, the question is, which type of sampling would we be looking at in order to answer the question? Let's take a look at the second one and see if we can come up with an answer to these two. The ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to all one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded, and 67% of them said no. So for these examples, let's then take a look. In convenience again sampling, whether it's convenient or not, so that would be the example of the first one. Voluntary response sampling again are people invited to decide if they want to give a sample or give a response for the sample or not. That would be an example of the second one. A simple random sample of size n consists of n individuals from the population chosen in a way that every set of n individuals has an equal chance to be the sample actually selected. In practice, people use random numbers generated by a computer or calculator to choose samples. If you don't have technology, you can use what's called a table of random digits. A table of random digits is a long string of digits 0 through 9 with these properties. Each entry in the table is equal likely to be any of the 10 digits 0 through 9. The entries are independent of each other. Knowledge of one part of the table gives no information about any other part. How to choose a simple random sample using Table D. Step 1. Label. Give each member of the population a numerical label of the same length. Step 2. Table. Read consecutive groups of digits of the appropriate length from Table D. Your sample contains the individuals whose labels you find. Example, how to choose a simple random sample using Table D at line 130 to choose a simple random sample for 4 hotels. So here are the numbers from Table D that are shown in blue. So we're going to choose a simple random sample of 4 hotels. The first numbers that appear in using 2 digits for all of the numbers, since the numbers go from 0 to 28, we're going to use 2 digits. If they went only from 0 to 9, we would use 1 digit. So we go through the first 2 digits, 6, 9, no, nothing here. 0, 5, yes, that's this one here, Beach Castle. We keep going again until we get to a number that would include the digits that we're looking for. So here again, we're showing which ones that we would use. As we get to the digits that include a number, as we number each of the different hotels, we would include those. Anytime a number is repeated, as you see, we don't include it in our count. So we have 5, 16, 17, and 20. And so these are our answers. Here's just another example of a way that you could use the digits. If we use, let's say, line 101 to select a simple random sample of size 3 stores, again we would number the digits, in this case 2-digit numbers. In this case, if you look at line on your table D, 101, you would find 19, and then 5, and then 13. A common alternative to simple random sampling is sampling groups called strata within the population. These subsamples, as they're sometimes called, are combined to form one stratified random sample. To select a stratified random sample, first classify the population into groups of similar individuals called strata. Then choose a separate simple random sample in each stratum and combine these simple random samples to form the full sample. Cell phones only. A growing percentage of Americans are dropping their traditional landline phones and using their cell phones exclusively. This has caused a problem for polling organizations who in the past only used landlines when randomly selecting people for their polls. Since the group of people who use cell phones exclusively are different in many ways than people who do not rely exclusively on cell phones, polling organizations now use a stratified sampling design that selects a random sample of cell phone users and a random sample of landline users. Although a stratified random sample can sometimes give more precise information about a population than a simple random sample, both sampling methods are hard to use when populations are large and spread out over a wide area. In that situation, we prefer methods that select a group of individuals near one another. To take a cluster sample, as it's called, first divide the population into smaller groups. Ideally, the cluster should mirror the characteristics of the population. Then choose a simple random sample of the clusters. All individuals in the chosen clusters are included in the sample. Here's an example. Describe how you'd use the following sampling methods to select 80 students to complete a survey. We'll start with a simple random sample. In a simple random sample, we would simply choose 80 seats at random on this group right here that's given. I would use a graphing calculator and use random int using the numbers 1 to 800, and then until you get numbers that appear, I would then use those 80 people for the survey. Remember that if there's a number repeated on your random int and your calculator, that you have to go to the next number that's not repeated. Stratified random sample. So stratified random sample, real simple. I would go by each grade level. Notice that the grade levels are listed in the different seats. So each strata is a grade level. Since I need 80, I would select 20 at random within each seating area. Each of the areas again represent a set of students by grade level. So for freshmen, for example, I would use 601 to 800, that's listed at the bottom here. For sophomores, I would use random int on the calculator for numbers 401 to 600. For 11th graders, 201 to 400 using random int, and again for 12th graders, use 1 to 200 using random int on the calculator. And once I have 20 selected at random within each seating area, freshmen, sophomore, juniors, and seniors, that would be my stratified random sample. For the cluster sample, I would look at the columns going down from the stage to the back, so front to back. Each cluster represents then all 4 grade levels. So I would select 2 clusters at random. There are 20 clusters because there are a total of 20 columns going across the room. And then select using random int 1 to 20 to get my 2 clusters. Give this survey to all of the people then in each column. That would be a cluster sample. Here's another example. A manager of a beachfront hotel wants to survey guests in the hotel to estimate overall customer satisfaction. The hotel has 2 towers, an older one to the south and a newer one to the north. Each tower has 10 floors of standard rooms, 40 rooms per floor, and 2 floors of suites, 20 suites per floor. Half of the rooms in each tower face the beach, while the other half of the rooms face the street. This means there are 2 towers times 10 floors times 40 rooms plus 2 towers times 2 floors times 20 suites, which equals a total of 880 rooms altogether. So, first question. Explain how to select a simple random sample of 88 rooms for this problem for the hotel. So the first thing we would want to do again is just look at what are we trying to use for our surveying sample. And in this case, we're using a simple random sample in order to figure out our answer. So this one is very straightforward, like with the other example that we already looked at regarding how we're going to figure out our answer. So for the regular simple random sample, I would go numbers from 001 to 880, which is our total. Use a random number generator, again probably the graphing calculator, to select 80 random integers from 001 to 880 and use those rooms from the sample. Very simple. Then the next one, how to select a stratified random sample of 88 rooms. So because we're looking at customer satisfaction is based on room location, whether they have a suite or whether they have a room in the south tower facing the street, we should take a sample from each type of room. So we would take a simple random sample of 20 from the 200 south tower rooms facing the beach, a simple random sample of 20 from the 200 south tower rooms facing the street, again a simple random sample of 20 from the 200 north tower rooms facing the beach, simple random sample of 20 from 200 north tower rooms facing the street. Then I would take a simple random sample of 2 from the 20 south tower suites from the facing the beach, 2 facing the street, 2 from each of the north tower suites facing the beach and street once again. The last one, explain why selecting 2 of the 24 different floors would not be a good way to obtain a cluster. Although it would be easy to collect data once the floors were selected, since you actually only need to visit 2 floors, each floor is more homogeneous than heterogeneous, meaning of the same, for homogeneous, which is not a good thing for clusters. So ideally, each cluster should include all the different types of rooms. If you only selected 2 floors, it's likely that you probably would get no suites in the sample or get only one of the towers in the sample. The purpose of a sample is to give us information about a large population. The process of drawing conclusions about a population on the basis of sample data is called an inference. To eliminate bias in selecting samples from the list of available individuals, we should rely on random sampling. Also, the law of probability allow trustworthy inference about the population. This results from random samples that come within a margin of error that sets bounds on the size of the likely error. And we'll talk later on about a lot more about margins of error. Larger random samples give better information about the population than smaller samples. Most sample surveys are affected by errors in addition to sampling variability. Good sampling techniques include the art of reducing all sources of error. Most sample surveys are affected by errors in addition to sampling variability. Good sampling techniques include the art of reducing all sources of error. Different kinds of bias and error include undercoverage, when some groups in the population are left out of the process of choosing the sample. We also have what's called non-response, which occurs when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of incorrect responses in a sample survey leads to what's called response bias. The wording of questions is the most important influence on the answers given to a sample survey. During the middle of the drive to pass healthcare reform legislation in July of 2010, several different polling organizations attempted to measure the sentiments of Americans. A New York Times CBS poll found 66% supported a government-administered health insurance plan, something like the Medicare coverage that people 65 and older get. However, a Fox News poll found only 44% supported a government-run health insurance plan. In our next lesson, we're going to be looking at observational studies versus experiments, all different types of experimental designs, and inferencing for experiments.